Okay, so we're going to start with our online lesson for chapter 13. Chapter 13 is on doing a 2-sample t-test and a 2-sample confidence interval. The good thing is that it's going to be similar to what you learn in chapters 10, 11, and 12, except that now we're going to have two of everything. 2 means, 2 standard deviations, 2 samples. Okay, so let me first go over the difference between a paired t-test, which you learned in chapter 11 and 12, and a 2-sample t-test. And that's the one that you're going to learn in chapter 13. So in the paired t-test, that's like, for example, I want to know if students perform better when they chew gum. So what I would do is I would get your class, and then for the chapter 12 test, you can chew gum. And then for the chapter 13 test, you can't chew gum. And I'm going to compare the results. So it's the same group of students. It would be period 2. The populations are dependent. So for example, if you're the type of students that always studies, then it's going to show in both tests. And if you never study, then the same thing will show. So the way you are affects the results for both. And then you'll be put in pairs. So you'll just be paired with yourself. So we'll compare your result in chapter 12 with your result in chapter 13. And then obviously it'll be the same sample size, because for both, it's the same class of 36, so the sample size will be the same. Okay, that's what we already learned. Okay, now what we're learning will be 2 different groups. So let's say, for example, I'm going to compare period 2 to period 3. So it's different groups. The populations are independent. So the results of period 2 do not affect period 3 in any way. And you're not going to be put in pairs. So I'm just going to compare the entire class. The results of period 2 with the results of period 3, but not any individual results. And we can have a different sample size. So for example, let's say I have 36 students in period 2 and I have 44 in period 3. And that's okay. I can compare the results for both. So these are the main differences. Again, that's the one that we did in the last chapter, and this is the one that we're going to be doing in this chapter. And then just 2 reminders. When you do the problem, always write the degrees of freedom. And there is a formula in your textbook, but you're not going to use it. You're just going to find the degrees of freedom by looking at the calculator. So I'll show you right now how you get that. Okay, so let me just show you the formula. It's a very long formula. But like I said, you don't need to memorize it. You don't need to know it. You're not going to use it. So the way you'll get your degrees of freedom is you're going to go to your calculator. And just like we were doing before, you go to stat, and then you go to the test. So you press the arrow. And then from here, what we're doing now is a 2-sample t-test. So that would be number 4. You choose that. And then if you have your list in L1 and L2, you choose data. If not, you choose stats. So I could choose stats. Okay, let me do that again. Okay, here we go. So I can input my stats. And then one thing I want to note is that it's going to ask you if you want to pull your data. Always put no. So if we knew the population standard deviation and we knew it was equal, we would put yes. But in reality, you don't know the population standard deviation. So for pulled, always put no, no matter what. So you put no, and then you can put calculator draw, either one. And same thing as before, it's going to draw the curve. It's a little slow, but it'll draw the curve. And then it's going to give you the p-value and the value for t. So the only thing with this is that it won't give you the degrees of freedom. So let me wait for the calculator to finish. Okay, here we go. So here's the value for t, and here's the p-value. Now if you want the degrees of freedom, then instead of choosing draw, you would choose calculate. And then the degrees of freedom are right here. So all you would do is you would just write that number down without showing any work or formula. Just put df equals 1612.85, and that's it. Okay, so what I'm going to have you guys do to practice the difference between these two is on Google Classroom. I'm going to send you this worksheet, and all you have to say is, are the samples dependent, which is what you learn in chapter 12. It's called a paired t-test, or are they independent, which is what you're going to learn right now. And then you just say what they are, and that's all. Okay, so let me just review the conditions. Okay, maybe you guys remember them because we use them for so long. Okay, so the 3 conditions are SRS, normality, and independence. Okay, same thing as before. So you check that it's random, it tells you or you assume. You check that it's normal. If n is greater than 30 or 25, you can use the central limit theorem. If not, then you can either graph the data and check if it's symmetrical, and that would mean it's normal. And if not, then we just proceed with the problem. And then for independence, you can say one doesn't affect the other, or the population is at least 10 times greater than the sample. Okay, the other thing that will be different in this lesson is the way that you write your hypotheses, but I'll do a separate lesson. So all we're going to do today is just go over how to create a confidence interval. So you're going to get a copy of these notes on Google Classroom, and this is a formula that you're going to have to use. Okay, the one that you had used before when we only had one sample was x bar plus or minus t, critical value, and then you had s over radical n. Okay, but now since we have 2 of everything, we have 2 means, 2 standard deviations, 2 sample sizes, the formula looks like this. Okay, so you'll be using this formula, and then the degrees of freedom will be either n1 minus 1 or n2 minus 1. You can pick the smaller one, but like I said before, the easiest thing to do is just get the ones from the calculator. Whatever the calculator gives you, that's what you write. And then this procedure here is not affected by outliers. So even if you have outliers, it won't affect your data. Okay, so let me go over an example. Okay, so let's say that you're looking at 2 threads to see how strong they are, and you get 50 pieces of each type. Okay, so now that's the difference, that before we would only have one sample, but now we're going to have 2 samples. So you have thread A and thread B, and you're going to get 50 of each, so the sample size is 50 for A and then 50 for B. And what we want to do is construct a 98% confidence interval. So the data is given to you. The sample size, that's n. The sample mean is x bar, and the standard deviation is s. And then, so now we have, everything will be double. So we have 2 of each. Okay, I wrote it here a little different, but it's the same thing. It's just vertical instead of horizontal. Okay, so just to review, when we do confidence intervals, you start off by saying what is x bar. So x bar, and then just a reminder, x bar is always the estimate. Don't forget the word estimate. You can write 1 sentence for each, or you can combine it in 1 sentence, which is faster. So x bar sub A and x bar sub B are the estimate of the average strength of thread A and thread B respectively. Or you can say x bar sub A is the estimate of the strength of thread A, and then another sentence. X bar sub B is the estimate of the average strength of thread B. But that's long, so you can just put it in 1 sentence. Okay, once you describe what x bar is, because this is a confidence interval, you don't have to write hypotheses. So you go straight into checking the conditions, which are SRS, normality, and dependence. So we assume that the samples are random. For normality, since both are 50, we can just say using the CLT, we assume normality. Just make sure you mention the CLT. And for independence, you can say the strength of one thread does not affect the other, assume independence, or you can say there's at least 500 threads of each, assume independence. Then after that, you name the interval. Okay, so this is a new one. It's called a 2-sample t-interval. And then you write the formula, the long formula that I showed you, this one. And then you write in the values, okay, but the way that you're gonna get the interval is on the calculator. Okay, so you're gonna go to your calculator and you're gonna go to stat, tests. This is an interval. It's called a 2-sample t-interval. So it would be number 0, 2-sample t-interval. You choose that, and then we just enter our information, which is right here. So x bar 1 is 78.3, S1 is 5.62, oops, N1 is 50, x bar 2 is 87.2, S2 is 6.31, N2 is 50, and then the problem says 98. Okay, so 98, I'm going to put 98. And then just a reminder, for pooled, always put no. So I put no. And then you put calculate, and it'll give you the interval and the degrees of freedom. Okay, so our interval is from negative 11.73 to negative 6.07, and then degrees of freedom 96.71. Okay, so you're gonna write that. So you don't have to show what this equals. You don't have to show all the work. Just write what it gives you, the degrees of freedom. And then the sentence is gonna be similar to what you did before. So you say, I am 98% confident that the average difference in strength between thread A and B is between, and then your answer, negative 11.73 and negative 6.07. Okay, so just to review, it's similar to what we did in the past, except that now you have 2 of each. So your first sentence will be different because you have A and B, and then the last sentence is also a little different. So you say the difference in strength between whatever 2 things you're comparing, and then of course the formula is longer, and that's the formula. And then on your calculator, you go to test, and then all the way at the bottom, it's the 2-sample t-interval. That's the one that we're doing. Okay, so what I would like you guys to do now is practice using the example that we just did so that you can do this one here, example 2. So just go back, and then you're gonna say x bar, you can call this A and you can call this B. X bar A and x bar B are the average, and this is about the mileage that you get. So it's the average miles that you get with octane A and B respectively. And then you would check the 3 conditions. You would write the formula. Okay, here's a summary of everything that you need. Okay, they didn't put N, but if you read it here, it tells you that it's 12. Okay, so N1 is 12, and N2 is also 12. And then you put it in the formula, then you go to your calculator, you choose this one, and then once you find it, you write your sentence. So I'll post the answer key to this so that once you do it on your own, you can check, and then you can send me a message if you have any questions.